Hello everyone, welcome back to Study Room. So in this video, we'll learn more about non-contact forces, pressure and many interesting experiments related to pressure. So let's move on. Now let's try to understand the relation of area and the applied force. What do? You take a nail and try to push it in the wooden plank by its header. Will you be able to do that easily? Of course, no. Now you do one thing, you rotate the nail and try to push it with its pointed end. Now you'll observe that the nail gets inserted in the wooden plank easily. Now why this happens? It happens because smaller the area, larger the pressure on a surface for the same amount of force. What are we observing here is that the area over which the force is applied plays a very important role in making the task easier, as we saw that the pointed end had a less amount of area and therefore it was easier to screw it in the wooden plank. The area of the pointed end of the nail is much smaller than that of its head. The same force therefore produces a pressure sufficient, that is, it produces a pressure more to push the pointed end of the nail in the wooden plank. Now, let's look at the definition of pressure. The force acting on a unit area of surface is called pressure. That is, pressure is equals to force per unit area. Pressure and area on which it acts are inversely proportional. Now, what does it mean by inversely proportional? P is inversely proportional to the area. So, what does it mean by that is that whenever the area will be large, the pressure will decrease. And if the area is small, the pressure will increase. Let's have a look here. Suppose if a force of 10 Newton is applied, the area on which it is acting is 5 meters square. Then pressure will be equals to 2 pascals. Now if we reduce the area for same amount of force, that is we reduce the area to 2, the pressure will be 5 pascals. Simple enough to understand, very easy. So therefore, smaller the area, larger the pressure on the surface of the same force and vice versa. Let's continue. Now we see an interesting activity to observe a pressure exerted by liquid at the bottom of the container. What do here is that we take a transparent glass tube of 25 centimeters and diameter should be 5 centimeters. Now we also take a rubber balloon. We stretch the rubber balloon tightly over the one end of the pipe. Now hold the pipe from the center. Now what do? We pour some water in the pipe. What do we notice? That the height of the water column in the pipe. Now what do? We pour some more water. Observe again the bulge in the rubber sheet. What do? We observe the bulge in the rubber sheet. It goes on increasing and the height of the water column in the pipe. Now we again and again we repeat this process. Now in this experiment, what do we observe is that the rubber sheet bulge out. It bulges out when some water is added and it bulges out even more when more water is added. So by that we can conclude that pressure exerted by water at the bottom of the container depends upon the height of the column. Simple enough. Now, we observe the pressure exerted by liquid on the sides of the container. Is any pressure exerted on the side? Let's see. We perform this experiment. We take a plastic bottle. Now we fix a cylindrical glass tube near its bottom on the side. Now we make sure that water does not leak from any joint. We take this precaution. Now cover the mouth of the glass tube with the thin rubber sheet, that is we can take a balloon. Now fill the water up to half with water. Here, what do we observe? We observe that the rubber sheet fixed to the glass tube bulges. And when we pour some more water, it bulges even further, obviously. So that's why we conclude that the bulging of rubber sheet in this case indicate that water exerts pressure on the sides of the container as well. Okay? Now, one more activity to observe pressure exerted by liquid at same depth. Now, let's take a plastic water bottle and we drill 4 holes near the bottom of the bottle. Now, when we fill the bottle with water, what happens? What do we observe here? Can you think for 2 to 5 seconds? Yes, what happens is that the different streams of water coming out of the hole falls in the same distance from the bottle. That's why we conclude that liquids exert equal pressure at same depth. Alright? Now, here's an interesting activity which can be done by you. You take a balloon and inflate it. Now, what if you do not tie a knot? What happens then? If all the air inside the balloon comes out. All your hard work goes in vain. That's why. And why does it happen? When we open the mouth, all the air escapes out. This suggests that air exerts pressure on the inner walls of the inflated balloon. That's why we conclude that gases too exert pressure on the walls of the container. So that's why we can say that both liquid and gases, they exert pressure on the walls of their each own container. Now let's see what is atmospheric pressure, and to understand atmospheric pressure, let's perform this experiment. A rubber sucker pressed on a surface. A rubber sucker, suppose if a rubber sucker is there and you press it on a smooth surface, what happens then? We see that it sticks to the surface. Now, why does it happen? It happens because most of the air which is present between the sucker and the surface, it escapes out. The sucker sticks to the surface because of the pressure of atmosphere which is acting on it. To pull the sucker off the surface, the applied force should be large enough to overcome the atmospheric pressure. Now there is some amount of atmospheric pressure acting on the sucker and it's difficult to pull the sucker off the surface. Therefore, we have to apply a force which is larger than the atmospheric pressure so that it comes out easily. Let's have a look at the definition of atmospheric pressure. The pressure exerted by air, by the surrounding air, is known as atmospheric pressure. As pressure is force per unit area, we all know that pressure is force per unit area. Therefore, atmospheric pressure is force of gravity per column of unit area. Simple enough, very easy. Now, have you ever wondered that there must be a force of gravity always acting on us? That force of gravity is equal to 2250 Newton. So, how is it that so much force is applied on our head and we are not crushed under the force of gravity? This is because our body has a pressure equal to the atmospheric pressure, which balances out the pressure and the resultant pressure is zero. Therefore, we are not crushed under this force of gravity. Now, there was this German scientist, Otto von Guericke. In the 17th century, he invented a pump to extract air out of the vessel. Now, what he did was that he joined two hollow metallic spheres of 51 centimeter diameter and he pumped all the air out of it. Then he employed 8 horses on each single side. Now, so great is the force of air pressure that the hemisphere could not be pulled apart. Even after employing 8 horses on each side, the hemispheres could not be pulled apart, and that was because because of the force of air pressure. So can you imagine how huge must be the force of air pressure? Now let's revise whatever we learned in this chapter. Broadly, we learned about force, pressure, different types of forces, the characteristics of forces. So now force could be a push or a pull. A force arises due to the interaction between the two objects. Force is applied on an object in same direction add to one another, and if they are in different direction, the resultant is the difference of the two forces. We already saw that. Force has magnitude as well as direction. If the two forces are equal in magnitude and direction, then resultant will be zero. Now, a change in the speed of an object or the direction of its motion or both implies a change in state of its motion. Force acting on an object may cause a change in its state of motion or it can cause a change in its shape. Moreover, force can act on an object with or without being in contact with it. Because of this, the forces are classified into two categories, that is contact forces, which are of two types, muscular force and friction force, and non-contact forces, which are of three types, magnetic force, electrostatic force, and gravitational force. The force of friction always acts on all the moving objects. It is necessary that a force of friction will always be present in all the moving objects, but it will always have a direction which is opposite to the direction of motion. Now, force per unit area is called pressure, that is P is equals to F upon A. Liquids and gases exerts pressure on the walls of their containers. Pressure exerted by water at the bottom of the container depends upon the height of its column. The pressure exerted by air around us, which is present in the surroundings, is called atmospheric pressure. This was all about force and pressure. We saw the different activities and many interesting experiments. Till then, thank you and see you next time.